Well, I guess I've already been introduced. I don't know if I need to introduce myself, but yeah, I'm the CEO of Moonsong Labs. Moonsong Labs, just to give a little description of that, we do a lot of protocol engineering development services, specializing in, not surprisingly, Rust, Substrate, blockchain protocol development, typically like lower level blockchain engineering type work. We are best known for our work on Moonbeam, although we do work on several other foundations, helping with their blockchain implementations at this point. I've actually presented at Polkadot Decoded since the very first one in 2020. So this is the fourth one this year, and I think that the theme of my talk is always kind of similar, right? Because the underlying vision that we've had when we chose to build on Polkadot was really this vision of we want to be close to an environment that has many blockchains. We believe that the interoperability between those blockchains is a key capability. And so every time I come back to Decoded, we've advanced a little bit further along that vision. And so, yeah, I'm excited to be here today to kind of make the next chapter in the story, right? And talk about some of the initiatives that we've been working on, and to really kind of describe a vision of like how you can have a multi-chain architecture, what a native multi-chain architecture looks like for a Web3 application. And so, so I wanted to start by maybe giving a little context and painting a picture of what the current landscape looks like. It's obviously changed quite a bit since 2020 when we started our work in the Web3 space. And we're in a time now where there are many chains, right? So compared to 2020 when we started, there's a huge number of chains now. When we started, really there was a binary choice, right? You could choose, if you want to build a chain, you're basically choosing between Cosmos SDK and, at the time, Substrate, as it was called, now Polkadot SDK, to build your blockchain, or from scratch, right? I mean, there's still some people doing it from scratch, less so these days. Now, I'll say most of the new chains being deployed are L2s. A lot of L2s on Ethereum now, and you have this landscape now of many different chains. I would say the thing that strikes me when I look out at the landscape is that the original Polkadot idea, an idea of, hey, let's have a tech stack, let's allow builders to build chains, let's connect them together in kind of a shared security and interoperability domain. That was a pretty strange idea in 2020. That required a lot of explanation. It doesn't require much explanation now, right? There's a lot of people who have taken, understand that this idea is correct now, and so you're seeing the same idea play out in multiple different ecosystems, right? So you have all of the L2s in particular who are pursuing similar ideas and saying, hey, use the OP stack or ZK stack to build a chain. It'll be part of an interoperable ecosystem. And so the kind of landscape that I see moving forward for the next several years is this kind of very fragmented one, this kind of balkanized state, but with kind of a coalescing of chains into these islands, let's say, islands of interoperability within this kind of this landscape. Of course, Polkadot is one of those kind of islands of interoperability, but there are others as well. But I do anticipate that for the next several years at least, developers will continuing to operate in an environment where you just have many different environments, many different ecosystems. And it becomes increasingly difficult to choose just one, right? And so that's why these native cross-chain approaches that I'll be talking about are very important to make sure that you don't limit your protocol, that you can kind of have the largest TAM that's possible. So let me talk about the vision a little bit that we had back in 2020, and then it's continued to evolve. So our vision really is there's not only that there's going to be many chains, but that these chains are going to specialize over time, right? That's a key capability, a very strong strength of Polkadot, right? Is this ability to use the Polkadot SDK to customize your chain. And so what does that allow you to do? So if you can customize your chain, you can optimize it for particular use cases. And we'll go through some examples of this. So by customizing and optimizing your chain for particular use cases, you can be highly efficient and highly scalable and do one thing and do it very well, right? I think of that old Unix philosophy of do one thing and do it well. The key is, though, usually when you specialize to something, that means you're less good at other things, right? So you're going to be really good at one thing, you're less good at other things. This is where the interoperability becomes quite important. By being part of an interoperable ecosystem, you can specialize and be good at one thing, but then rely on other people who have different kinds of specialization to do other things really well. And this is kind of where we start to get to the theme of the talk. I called it the whole is greater than the sum of its parts. So each chain on its own is valuable, but when taken together, with many other chains that are specialized in different ways, you get this kind of network effect. You get this whole is greater than sum of its parts effect. And so that's the thing that kind of excites me about, from even in 2020, that's what excited me about Polkadot, and still to this day is something that it motivates me quite a bit. And so to paint a picture here, we're operating, usually building different kinds of infrastructure chains. Moonbeam itself is an infrastructure chain. And so imagine that you have different kinds of specialized chains, perhaps providing block space or compute, perhaps providing storage, different kinds of specialized infrastructure services. The mental model I use is something like AWS, right? As a Web 2 developer, you log into AWS. You have this whole menu of different kinds of specialized services. And then as a developer, you pick and choose the components that you want. And you can build a super scalable application on top of those specialized services. And so I think that Polkadot offers a great platform for creating something similar, but that consists of decentralized Web 3-based services instead of centralized cloud-based services like you'd find in a normal cloud provider. And so that's been like a motivating kind of vision for us for a long time, is to create these specialized infrastructure services, allow for the coordination to tie them together so that you can create these very scalable and chain-agnostic user experiences, just like you do in Web 2. And then not only that, but you can extend those services out to reach users and assets that are on different chains, right? That are on wherever they are in this kind of like very kind of balkanized and many chain landscape that's out there. So that's the that's the vision. So let's talk a little bit more about the motivations and drivers, right? So as a developer, if you look at the latest Electric Capital report that tracks GitHub activity and tracks a lot of information about like Web3 developers, what tools they're using, what ecosystems they're in, and so on. And I think the theme from the last report was that multi-chain or cross-chain is the new normal. So most devs now that are starting in Web3 are building with like a multi-chain mindset from the start. Like, why is that? It's driven purely from a practical perspective at this point. It might have been the case back in 2020, say, that you could choose one chain and say, hey, I'm going to just deploy here, I'm going to service the users on this chain. Guess what? That doesn't work very well now when you have hundreds and hundreds of chains. Your market is quite small. It's the same as saying, hey, I'm going to start a business and I'm only going to operate in this one city. Well, it makes much more sense to operate in like many cities to offer services to people that are in across the country, across the world, maybe even. So this total addressable market is probably the key driver that's driving people to extend out and find users and assets that they can service wherever they are. But there is this point about scalability and efficiency. In order to scale, this is the key Polkadot idea, is in order to scale, you need to parallelize execution. There are some chains out there that are very high performance. Take Solana as an example. They're able to eke a bunch of performance out of one chain, but guess what? Like, no matter how fast your single chain is, you're going to run out of capacity at some point. And at that point, you need to pursue like some sort of parallelized execution strategy. It can take different forms. It could be L2s on Ethereum, for example, but you're going to have to parallelize at some point. And so I think being thoughtful about that and kind of building like an architecture that supports this idea of having multiple threads of execution is ultimately the key towards scaling to like very large numbers. So the scalability through the efficient combination of different chains is another idea. And then this like UX, right? So there's a lot of folks that, the UX in Web3 is challenged. We know that. And I think that what you see more and more these days is people creating abstraction layers to separate users from the underlying chains that they're working with. And so that's another key trend and motivation for going cross-chain, is that if I can kind of get the user out from knowing even what chain they're on, well, now I can start to leverage many different chains in the background, right? And create a user experience that cuts across all of them. And so that's an important kind of unifying concept that's happening at the front end. So what I wanted to do here is I'm going to introduce you to a cast of characters. So I want to tell this kind of multi-chain story, paint a picture for you of an example of a multi-chain architecture. But it relies on a number of different chains or services in the story. So I want to just quickly introduce you to each of these characters in this story. We'll start with Moonbeam. That one is obviously very close and near and dear to my heart. And in the context of a multi-chain architecture, what role does Moonbeam play? Really what it plays is kind of this like integration or interoperability hub, right? So from the start, the idea around Moonbeam was, let's the sacred principle for Moonbeam was we need to be 100% compatible with Ethereum and the EVM. What does that get you? That gets you basically compatibility with the entire Ethereum dev toolchain, as well as the end-user tools, like MetaMask, for example. It also means that you are the easiest place for third-party services to integrate, because they already have EVM or Ethereum-based integrations. So you can see, as an example, I mean, all the bridges that are on Moonbeam, they were designed to work with EVM chains, so that's why Moonbeam has things like Axelar, Wormhole, Layer 0, Hyperlane, and the list goes on. And so we'll see that, like, as part of this story, Moonbeam becomes this kind of like integration hub, a thing, a place where shared services can be found and leveraged, and a place where different kinds of services can be accessed from other chains. The second character in the story is a project called Tansy. Many of you have probably heard of it if you've been building in the Polkadot ecosystem. It was born from experiences that came from the implementation of Moonbeam. Moonbeam is optimizing for EVM compatibility, has these specific goals. And guess what? Whenever you do that, you're less good at other things. So for example, if you have a use case that requires a large degree of, a large amount of block space, a large amount of transactional throughput, Moonbeam may not be the best fit there because it's made sacrifices on throughput in order to provide this very rich compatibility, or this full compatibility. And so what Tansy allows you to do is, deploying a chain is not that easy, right? It's much harder than a smart contract. And the whole idea of Tansy was, what if we could make deploying your own chain as easy as deploying a smart contract? And the team has really taken that idea and run quite a bit with it. So they've done an amazing job. This is it's not deployed yet, but it will be deploying to production soon. And that North Star is something that they're achieving, which is, get me from 0 to a deployed, fully operational L1, decentralized L1, in a very short amount of time, right? In a matter of in one session, not 6 months, not a year. I think we probably worked on Moonbeam for a year before we had something deployable. And so you'll see that this will play a role in the story I'm going to tell, this Tansy service, which provides a whole set of shared infrastructure services to make that deployment super, super easy. Another kind of player in the story is something called Storage Hub. Some of you may not have seen or heard about this. This is a project that Moonsong Labs were working on the code base or the technical implementation for Storage Hub. Storage Hub is a decentralized storage system. So it's a chain that specializes in storing large files and large data sets. Why is this an important specialization? Storing files is a use case that comes up a lot, like when you're building dApps. And people have all sorts of solutions they've come up with this of, okay, we'll have that part be off-chain, we'll put a hash on-chain, we'll do these tricks to try to get around this. Storing files on a system like Moonbeam or an EVM chain does not work well at all, right? These systems are not designed to store data. When you store data on Moonbeam, you pay a large amount, and then all the full nodes have to carry that data till the end of time. So it's a very, very expensive thing to do. It's not designed to do that. Storage Hub is designed to do that, right? So it's designed to store files in a very efficient way, a subset of nodes that carry the state. If payments to store the state stop, then the storage stops. You can have different kinds of storage providers that are optimized for different use cases. So again, a very specialized chain. The key, and there's other examples of this, like Filecoin, Arweave, that you see out there. The difference on Storage Hub is that it's been designed from the start to work alongside other chains, right? So it does not assume that everyone has all their logic on Storage Hub. It's just providing a storage service which can be remotely accessed from smart contracts on Moonbeam, say, container chains on Tansy, using XCM as the primary communication means on Polkadot. So this is an interesting thing. So this is, again, one of those services in this shared list of services that developers can now use, and it's designed to work with some of the other chains and other systems they're using. So looking forward to this, if you look in the context of a traditional AWS-based application, the storage, kind of S3 storage, is usually a big component of those apps, depending on the use case. So last but not least, the last kind of character in the story is a project called Glacis. I see some folks from Glacis here, so that's great. So Glacis was, again, of course, some of the original ideas were born from experiences we had on Moonbeam. And this has to do with this TAM concept. So when you're a developer, the developers are local to the chain are great, But it's a big world out there. Most of the developers you're trying, or most of the users you're trying to get to, or assets you're trying to get to, are not on the chain that you're on. Even if you're on Ethereum mainnet, that is basically true at this point. They're on L2s or somewhere else. So how do you get to them? The status quo right now on approach is using a bridge, right? I named off some of the popular ones these days: Axelar, Wormhole, Layer 0, CCIP. So the default thing that developers do these days is, okay, let me pick one bridge, integrate into my system, and hope for the best, right? And when you've been building the space for a while, that hope for the best part, you know that that's not always true. Like, there's things that happen. And so I think the idea for Glacis was, how can we make this safer for people, right? How can we make it so that if there's a catastrophic bridge failure, a hack, that doesn't cause a catastrophic failure to your application? And so the concept or the idea behind Glacis is, let's build, it's inspired by networking, right? So imagine like a network router. A network router has a number of interfaces, and you can plug different network connections into it, right? So imagine that those network connections are like the bridges. So right now, Glacis supports, I think, 5 different bridging protocols. So Axelar, Wormhole, Layer 0, Hyperlane, and CCIP. But it allows you to control the flow of traffic across those bridges. So a couple scenarios I'll throw out at you. One scenario is failover and redundancy. So let's say like my primary path, I want it to be Axelar to reach like users and other assets on other chains. If Axelar is having a problem, failover like to Wormhole. Use Wormhole as like the backup for redundancy. This is a technique that's been around in networking for a long, long time. Like IT guys, they don't want to be woken up in the middle of the night. They want, okay, yeah, there's failure, it's happened, okay, like it failed over to the backup, great, we're good to go. That's not how Web3 development goes when it comes to cross-chain typically. So we want to bring some of these like maturity and reliability ideas into Web3. I'll give you another like example that's popular with Glacis. Imagine like a high availability setup. So you can set up a 2 of 3 quorum. You can say something like, all right, use all 3 of Axelar, Wormhole, Layer 0 to like perform the cross-chain action. Require 2 of 3 of those to like reach the destination before forwarding it. So now in this situation, you can have a complete failure. Like any one of those 3 bridges can be totally hacked. Your application will still run normally, right? Because 2 of the 3 are still functioning, and then you achieve this 2 of 3 quorum in order to forward your messages. So we believe this is a great like kind of safety improvement, a great reliability improvement, and it's something that like will allow people to reach out to like access users across the splintered landscape in like a much easier and safer fashion. And so this is this is something I'm pretty excited about. As a project. And so. So all these different scenarios. So let's try to like pull it all together here into a story now that you've met all the kind of the cast of characters here. And I spoke with Marin like recently, who's sitting over here, to find a good example. There's many examples, but I wanted to choose one that I thought fit the scenario well. So the scenario is they're developing a game called The Great Escape. They've been building on Moonbeam for quite some time. This game has several elements in it, right? So the game has an on-chain component for gameplay. It's got NFTs, so there's NFTs that are part of the game that one can purchase. There's a fungible token that is part of it as well. And a lot of those requirements I talked about, they want to reach obviously as many users as they can. They want to reach people to play this game. So now, how do these elements come together in kind of a future direction for The Great Escape? They started on Moonbeam. One of the challenges, though, whenever you're in a shared smart contract environment, is this on-chain component, right? So you have this on-chain component that's part of the game logic. Prices are not like fluctuate on any like shared smart contract chain, right? If there happens to be like a lot of activity, the prices will go up. You have less activity, prices go down. That can be a challenge. That can be a challenge for some use cases, right? If you want to have something cost exactly the same amount every time, that's something that like is difficult to achieve on a smart contract chain like Moonbeam. So a container chain, a Tansy container chain, allows them to kind of purchase the block space up front. They can guarantee kind of the same cost to the user like as that gameplay is unfolding. So that's like a consistency. That's like a user experience kind of improvement that they can make. And a container chain makes sense like for that to kind of control the compute. But on that container chain, you have this blank chain. You don't want to recreate everything that's on Moonbeam, right? I mean, Moonbeam has a lot of services on there. It's got NFT marketplaces. It's got like a whole DeFi ecosystem, DEXs, lending and borrowing. And so you want to be able to leverage those. So here's where you can start to get synergies, right? So like, OK, my game engine is on a Tansy container chain on its own. But the NFTs and fungible tokens that are associated with my project, well, geez, it makes sense for those to be on Moonbeam because there's all these other protocols and services that those tokens can interact with and the users can use for different purposes within the shared Moonbeam EVM environment. So that makes sense. How about Storage Hub? Well, you guys, as you know, when you have NFTs, often there's going to be metadata associated with those NFTs, right? So you have an NFT, it's a contract living on Moonbeam. It could be an ERC 721 or other kind of contract. There's like images, right? Media files, could be video, like other files associated with you. Well, now those are not good to store on Moonbeam, as I said, but now you store those on Storage Hub. You can kind of have this true NFT idea, right? So the contract is on Moonbeam, specialized for smart contract execution, but the media files associated with that NFT are on Storage Hub, and the contract on Moonbeam can control those media files, right? So there's a connection, an XCM-based connection between the two. So already you can see here, now you have 3 different chains, each specialized to like a different function, but they're all working together to create like one user experience, right? They're all doing their part to create this overall single user experience. And so how about Glacis? Like, where does Glacis fit in? Great that you have this functionality, you have these 3 specialized chains. How do I bring those game players into the game from wherever they are, anywhere? This is where Glacis comes in, right? So without having to pick a single bridge, without taking on single bridge risk, you can now extend out, and I believe one of the functions they have is a deposit automation function, where users can deposit from a whole bunch of different like origin chains to basically pull them into the game. Well, now you can do that in a bridge agnostic way on any source chain, right? Any origin chain, and do it in a way that doesn't introduce bridge risk, or you can manage the bridge risk about doing that outside of this kind of more secure environment where all 3 of these other chains are running within this XCM-enabled Polkadot environment under the same security domain. And so I think this is really cool, right? So you can have multiple different services, multiple different components. They're powering a single user experience, but like each one is specialized to a particular function. But you get like more out of the combination of these 4 things. If you tried to do all these things in one place, you would not be able to do it. There's inherent trade-offs whenever you're building these blockchain systems, right? So you need to kind of specialize and combine to be able to get this whole is greater than the sum of its parts effect. So yeah, I think there's many examples. There's DeFi examples, there's other examples, but I wanted to use a tangible example. And I'm glad I see the team, you should talk to them, is in the room right here. So that's great. Just comment a little bit on future directions. What do we see and what are we working on? It shouldn't be surprising to everyone that a lot of the developer activity these days is on Ethereum mainnet and its L2s. I think that Polkadot has a lot that they can offer this like modular ecosystem on Ethereum. So again, back to this, you have to pick and you're making trade-offs. Rollups, they make a trade-off, right? So they make a trade-off. They have a lot of throughput. They do get security from like the underlying like base L1. They are bad at like decentralization, that's for sure. They are bad at customization too. I mean, you're basically, it's like any color you want as long as it's an EVM, right, is what you have on the rollups. Think about trying to implement something like Storage Hub on an EVM. That's like it's not going to work well, right? You need to be able to customize like the chain to optimize it for certain use cases. And so a lot of the things we're exploring now are ways that, how can we take these specialized services on Polkadot and, allow them to be supporting cast members to this like modular ecosystem like on Ethereum. And this is where, the customizability, decentralization properties, finality properties, that's something that Polkadot-based services are very strong on. Really can fill certain needs that are not well served right now on Ethereum mainnet and its L2 ecosystem. And so these are some areas that we're doing research on now. And I know that there's some other projects like Hyperbridge that are also thinking along the same lines about how can we export Polkadot-based services into other ecosystems as useful infrastructure. So yeah, I think that's what I wanted to talk to you guys about today. If you want to learn more, you can feel free to visit our website. Also, feel free to find me here afterwards if you want to chat. And thanks very much.
Wow, thank you so much, Derek. Whoa. We do have time for some questions, Derek, if you would like to stay on stage. This was a great history and update what Derek and team has built. I would actually also like to know, you covered it a little bit, but what were the driven factors for you specific or personally and the team always to come up with the architectures that you just presented? Because it evolved from Polkadot, you were the first EVM compatible parachain. What were the driven factors for the team?
I think for me, like, I'm kind of old, usually relative to other people around, but I like to draw a lot of comparisons and analogies with, like the IT environments I grew up with, right? So like, I often think there's that old saying that, history doesn't repeat, but it rhymes. And so like a lot of the same concepts, I talked about Glacis, for example. Glacis, a lot of the core ideas there came from like living that life of like being an early network engineer and getting woken up in the middle of the night when like network connections were down and saying, well, how do we deal with this situation? So I kind of saw this problem and solutions to it in a different domain.
Yep.
And then it's like, okay, how can maybe some of those ideas be applicable when applied to cross-chain? So I think that's, that's one thing I'm always thinking about is like this pattern recognition and trying to figure out, okay, I've seen something similar, and maybe that informs, or gives you some opinions about how we could solve certain problems I'm seeing now.
Amazing. Yeah, this knowledge is very important. We don't need to reinvent the wheel, but just make it better and more efficient.
Yeah.
Great. Other questions from the audience? No, Moonbeam OGs in the room. So, but I think the team is here. Derek will be around if there are more questions. Thank you so much again.
Thank you.
Woo.